Introduction to Neural Networks with C#, Class 1, Part 2. Hello, my name is Jeff Heaton. This is Part 2 of Class 1. This part will show you how to solve problems that are commonly used for neural networks. If you're just joining us, this is actually Part 2 of Class 1. You may wish to review Class 1, Part 1 before continuing with this section. This class discusses problems commonly solved by neural networks. This includes classification, prediction, pattern recognition, and optimization. Classification is how a neural network is used to classify pieces of data into several groups. Prediction shows how you can use a neural network to look to the future to determine how a data set may evolve over time based on previous results. Pattern recognition shows how to recognize patterns in data and identify what that data is. Optimization allows the neural network to optimize data for a particular task. We're going to look at each of these in detail, but first let's look at classification. Classification is commonly used for spam detection. Consider the emails presented here. Here you see the emails are broken into obvious spam, potential spam, and good emails. The neural network learns from emails that come in and accepts training from the user as far as when the neural network gets things right and when the neural network gets things wrong. This allows the neural network to better detect spam or not spam emails. Another example of classification is mortgage risk. Here you see mortgage applications coming in. In similar fashion to the spam or no spam detection, the neural network classifies these mortgage applications into standard risk or substandard risk. The neural network will learn about this based on experience with actual applications coming in, as well as historic applications that the company will use to train the neural network. Prediction is another common use for neural networks. Here you can see the S&P 500. We can see the stock's prices fluctuating coming up to the present time. What we want to predict is the future. We feed these values from the neural network, or from the S&P 500 into the neural network, and it detects patterns. And this allows it, to some degree, to make predictions and assumptions about future movements in the S&P 500. It's often applied more to individual stocks or how individual stocks can predict each other. And interest rates are often factored into this as well. Pattern recognition is another classic form for neural networks. Neural networks can be used with pattern recognition to recognize letters of the alphabet or anything. A human can easily recognize different types of stop signs, like you see here. These all look somewhat different. A computer can't tell them apart, but a neural network could be trained to recognize these patterns and actually provide some insight into the fact that these are all pictures of the same type of thing. Finally, optimization. Optimization is a way to optimize things. You can use the traveling salesman problem for this. This is where a traveling salesman must visit a number of cities and find the shortest route. You can also use optimization on circuit boards where you want to minimize the amount of distance that the electrons have to travel. Neural networks are very good at this sort of thing and can often optimize by learning the characteristics of what they're trying to optimize. So far we've shown you what neural networks are and what they're used for. In the next part of this class, Part 3, you're going to see how to actually construct a simple neural network that can solve a couple of simple problems. You're going to see neural networks at the very basic level, but you're going to see how to construct an actual neural network. This is covered in Class 1, Part 3, which you can view next. This course is based on our Introduction to Neural Network Programming books for Java and also Introduction to Neural Networks for C#. Available in both paperback and ebook format.